All right, if you're gearing up for the AREs, you already know HVAC can be a beast. It's all over the PPD and PDD exams, right? Well, today, we're going to tackle that head on. We're breaking down the 4 essential systems you have to know to pass. Let's get these locked in so you can walk into that exam with confidence. Okay, so picture this. This is the classic problem, right? You've got a conference room, a corner office getting blasted by the sun, and a tiny data closet that's cooking itself. How in the world do you keep everyone happy? One space is freezing, another is boiling, and they all have totally different demands at the exact same time. This is the puzzle we're going to solve today. So yeah, we're going to dive into the 4 main systems that are guaranteed to pop up on your PPD and PD exams. We're not just talking theory here. We'll get into what they are, how they work, and the big one for you as an architect, when to use which one. Let's do this. First up, we've got the foundation, the OG of HVAC systems, constant air volume, or CAV. You really got to get this one down because everything else we talk about is basically a reaction to it. It's our baseline. You know, the name gives it all away. With CAV, the fan is always blowing the same amount of air. It's a constant volume. So how do you control the temperature? Simple. You change how hot or cold that air is. If a room needs more cooling, the system just sends colder air. If it needs less, the air is a little less cold. But that fan, it's always blowing at the same speed. Here's the best way to think about it. Imagine you have a hairdryer, but the fan switch is broken and it's stuck on high. It's just always blowing at full blast. The only thing you can actually control is the little dial for the heat. That is a CAV system in a nutshell. The blow is constant. You just mess with the temperature. So, why would anyone use this thing? Well, on the plus side, it's dead simple. It's cheap to put in, and it's pretty reliable. But, and this is a huge but, the downsides are massive for most buildings today. That fan running full tilt all the time, it just burns through energy. And it's awful at zone control, which means some people are freezing while others are sweating. And that really is the million-dollar question, isn't it? The cost of that simplicity is just tons and tons of wasted energy. You're chilling all this air and blasting it everywhere, whether a room needs it or not. It's just wildly inefficient. And that exact problem, well, that's what led to the next system we're going to talk about. Okay, enter the game changer, variable air volume, or VAV. This is the smart, efficient answer to CAV's energy problem. Seriously, this is the system you're going to see in pretty much every modern office building you walk into. So VAV completely flips the script from CAV. Instead of a constant volume of air at different temperatures, VAV gives you a variable volume of air that's always at the same temperature. The main unit chills all the air down to, let's say, 55 degrees. Then, the real magic is that each room, each zone, gets to decide exactly how much of that cold air it wants. And why does this matter so much? One word, money. Or, well, energy savings. Just by delivering only the air that's actually needed, you can slash your energy bill by up to 30% compared to a CAV system. That is a huge number, and you can bet it's something you want to have in your back pocket for the exam. And this little guy right here is where all that magic happens. This is the VAV box. It's usually tucked away in the ceiling. See that flap inside? That's a damper. When the room's temperature is just right, the damper stays mostly shut. But as soon as the thermostat senses things are getting a little warm, it tells that damper to open up and let in more of that nice, cool 55-degree air. It's a really simple and smart solution. Okay, ARE exam tip time. If you remember one thing, it's this. VAV equals energy savings. How? 2 ways. First, the main fan can actually slow down when it's not needed as much. And second, you get that super precise zone-by-zone temperature control. It's pretty much the gold standard for efficiency in most commercial buildings. But wait, VAV isn't a silver bullet for every problem. You're going to run into some weird situations where you need something a little more specialized. And that's where our next 2 systems come in. Think of them as the problem solvers, terminal reheat and Dual-Duct. Okay, let me set the scene. You've got this big conference room, right? It's designed for 20 people. Now, the code says you have to pump in a certain amount of fresh air all the time for ventilation. But what happens when there are only 2 people in there? Well, that minimum amount of cool air can actually make the room way too cold. Now you've got 2 people shivering in a huge room. That's the problem. So what's the fix? It's called terminal reheat. Basically, you take a normal VAV box and you add a little heater to it at the very end. It could be an electric coil or one with hot water. So now you're still getting that required fresh air, but if the room starts to get too chilly, this little coil kicks on and warms that air up just a bit right before it enters the room. Problem solved.
So where do you actually use this? There are two main places. The first is along the perimeter of a building. You know, the exterior zones where you're losing heat through the walls in the winter. The second is exactly like our conference room example, any space where the minimum ventilation would make it too cold. Now, it does feel a little weird to cool air down just to heat it up again, and yeah, it can be inefficient, but sometimes it's just what you have to do to get the job done right.
All right, now for the heavy hitter. For the most critical, demanding spaces, you have the dual duct system. The easiest way to think about this is like a sink faucet. You've got a hot tap and a cold tap. A dual duct system is the same idea, but with air. You literally have two ducts running everywhere, one full of cold air and one full of hot air. Then a special mixing box blends the two streams to get the exact temperature you need for that one spot.
And you can see how it works right here. You've got the cold duct coming in on one side, the hot duct on the other. This mixing box gets the call from the thermostat and blends them perfectly before sending the air into the room. And because you have both hot and cold available all the time, you can go from full-on heating to full-on cooling in a split second. It is by far the most responsive system you can get.
Now, this system sounds amazing, so why isn't it everywhere? Well, it's complex, it's expensive, and think about it, you need space for two giant ducts running everywhere instead of one. So you only break this out for the really critical stuff. We're talking hospitals, labs, operating rooms, any place where having precise instant control over the temperature isn't just a luxury, it's an absolute necessity. Okay, that was a lot, I know. So let's wrap it all up with the ultimate cheat sheet. Seriously, get your phone out because you're going to want to screenshot this one for your study notes. Okay, let's do a quick lightning rounds. CAV, constant air, changing temp. It's simple and cheap, but an energy hog. Think small buildings. VAV, changing air, constant temp. This is your modern workhorse, efficient and great for zone control. Terminal reheat, that's just a VAV system with a little heater attached. Perfect for those tricky exterior zones or low occupancy rooms. And finally, dual duct, mixing hot and cold air on demand. Super responsive, but also super expensive and space intensive. You save this one for hospitals and labs. So here's the final takeaway. This stuff isn't just for the engineers to worry about. The system you choose has a huge impact on your architecture. Are you going with dual duct? Well, you better plan for a much deeper ceiling plenum. Using the AV, you need to think about where all those access panels for the boxes are going to go. So see, understanding this isn't just about acing an exam, it's about becoming a better architect.